Okay, hopefully you can hear me. I'm hoping that the mic check is working to satisfactory. But welcome to your flipped classroom experience. This is a method we will be using throughout the year, not for all units, for all concepts, but we wanted to get you exposed early on so you can understand what you will be held accountable when we turn to flip classroom experiences. Flip classroom basically is asking you to do something prior to entering the classroom. Might be copying notes, recording definitions, finishing an activity, watching a video. And so today your video will be of your notes that we're going to get into. If you were present, we saw the basic ideas of geometry and the reasons for labeling. And we're going to go in a little bit more depth with some of the Euclidean geometry, or the foundation of geometry that was built upon, and that we're going to use when we have to start proving theorems in the next couple of units. So geometry is just a mathematical system built on accepted facts, basic terms, and definitions. And the first new term or definition you're going to use is what we have is a postulate or axiom. And a postulate or axiom is just a rule or statement accepted as true. Statement. Oops, I'm out of room. Excuse me. Make some room. Statement. I just kind of went straight into it so we can get this done. I'm trying to limit our videos to a certain amount and an amount of space. What you have and what you picked up today was a Cornell style form of notes. Your notes have the main information on the right side and your main ideas and questions that you use to help you study your bullets on the left. So whenever we have Cornell notes, anything that you see as bold, odds are it's going to be important. So you're going to need to know that term or that definition and what it means. So right now we got postulate and axioms. The next thing we're going to get into is a theorem. A theorem is a statement that can be proven. Okay? Basically it's just a statement that can be proven. And that statement that can be proven is proven using our postulates and our axioms. Okay? That can be proven. Now, the reason why we do flipped classroom is to get everyone a front seat to their lesson and to their understanding. And so at any time, if something is going too fast, that's your opportunity to rewind. If something's not going fast enough, you can fill in the blanks. You can fast forward. So our foundation in geometry, Euclidean geometry, is based on 3 undefined terms in which we're going to use these undefined terms and accept them as true and build theorems and actually prove theorems from them. Our first undefined term is a point. Okay? A point has no size. Okay? I know you're used to looking at it as a dot on a graph or on a piece of paper, but a point has no size, and in a figure, a point is represented by a dot. So our basic ideas that we're going to use here that correlates this reasoning and this labeling that we're going to do correlates with section 1.1 in our online book. And you're going to be expected starting off to draw and to label correctly. And we kind of did a little mini activity on why we label and how we label. So the first example you have is just draw and label point A, point B, point C. So take the time to do that. If you want to just go ahead and do that, or just fast forward. But basically, I'm just looking for a dot, and you have to have a capital A next to that dot. Okay? It could be anywhere, because it's basically a point is representing some type of location in space. Some type of location in space. And whenever we label, we're going to use capital letters to represent points. Okay? So just remember capital letters. And that's one of the things, these bullets we have over here. How do you name a point? Okay? You have to use capital letters. Another undefined term in geometry, and let me get these highlighted for us. We have points. We're going to also have a line. Okay? A line is an infinite series or set infinite series or set of points. A line extends in both directions, okay? It extends in both directions. Both directions, sorry. And has no thickness. Okay. Now, because it's extending in both directions, it's endless. So it extends in both directions endlessly. Forgot to put that. Some of you might understand what I mean. So, see if I have this point A here. If I add another point next to it, real close to it, another point close to that one, another one close to that one, and I continue like an infinite series, like it keeps going forever and ever and ever, eventually you will see, and that's not very straight, but eventually you will see a line being formed there. And so, to have an infinite series of points creates the line. Now, there's postulates, and what are postulates again? Rules or statements that we accept to be true. There are postulates that we have with points, with lines, and with planes, which is the third undefined term that we have in geometry. The first postulate is the two-point postulate. The two-point postulate basically just says that through any 2 points, there is exactly one line containing those 2 points. Okay? So, through any 2 points, there's exactly one line. Now, your example that you have on your notes is line T is the only line that passes through points blank and blank. So if you look at the diagram that you have, which points are on the line? We have points points A and B. Okay, now let's get into the labeling because that's what's really important for this postulate. We name a line 2 different ways. Basically, with the 2 points that contain that line, that are on that line, and we would use capital letters, so point A and point B, and we would put a line symbol above the points. I'm hoping you can see that. Now, order does not matter. So line AB is the same thing as BA, as such. The other way we name a line is with words, and we say line, and then we use the subscript. The subscript is going to be in a lowercase letter. So right here, we have line T. So there is how we name lines. Make sure you remember you're going to use script lettering or capital letters of any 2 points on the line and a double arrow above them. So one of the things they're going to ask is, how do you name a line? Well, I'm not really going to ask you to put that in words. I'm just going to ask you to show that with symbols, the correct symbols, whenever you are identifying the lines off of different figures. Now, our next postulate, that we have that we're going to use is a 2-line postulate. Basically, the 2-line postulate states that through any, if 2 lines, after 2 lines intersect, then their intersection is in exactly 1 point. Exactly 1 point. So, I know that point is not noted on this example or this picture they have here, but we have point A, point B, point D, and point E, and that point right here where they intersect is going to be the intersection. So the intersection of these 2 lines, notice they have it in symbol, and this is the way you are going to see it, and the way we're going to write it is using symbols, and you have to be able to read that. So this basically says line AE and line BD intersect at, and you would just say point C. Now, what we're going to get to here is going to probably be some new vocabulary, but you're going to use your prior knowledge and what you did in Algebra 1 to help you problem solve and break down our terms, new terms especially. So we have the term collinear. And many of you are familiar with the word linear. You worked with linear equations last year. When you graphed a linear equation, it looked like what? Hopefully you're going to say a line. You graph different types of lines with different slopes, have different steepness. So if it's collinear, okay, then it's, think about that. If you are codependent or if we coexist, right? We have a collinear points, okay? So we're talking about collinear points. Collinear points are on, basically, the same line. So if collinear points are points that are on the same line, then points that are not, if they are not on the same line, then we just call those non-collinear. Okay? So you need to know collinear, and you also need to know what non-collinear points are. Okay? You're going to have to be able to identify if they're collinear or non-collinear or not. And then our last basic undefined term in geometry is what we call a plane. And a figure of plane is often represented by a parallelogram. If you forgot what that was, most people think of it as a side or slanted rectangle. It's leaning to the side one way or the other. Now, you're going to have to be able to name a plane. When we're naming a plane, we're going to use capital script letters or 3, and this is important right here, non-collinear. I probably should put that in red. Or we're going to be using 3 this is important, non-collinear points on the plane. So remember, what does it mean to be non-collinear? It means they're not on the same line. So notice that we have a slanted rectangle here, and we have this capital script letter. So this is the capital script letter over here. Forget my handwriting, sorry. And then we have 3 non-collinear points. The reason why these 3 non-collinear points are, we have a line, because our line postulate, or 2-point postulate states that there's exactly 2 points that go through a line. So A and B are on the same line. And I could draw a line through A and C. Those 2 are collinear. I could also, hopefully you can see, you draw a line through B and C. We have 3 distinct lines, 3 points of intersection, but those 3 points never lie on the same line. Therefore, because if I have points that are on the same line, I could just end up with a line and not a plane. And most planes that extend in every direction, if I extend this in every direction, most planes start off as a rectangle, but if I mean a triangle, if I extend it in every direction, it continues on and on and on. So make sure you understand this is really the basic labeling points, how to label a line. Our symbol for plane would be the slanted rectangle, or basically the parallelogram, and you would name the plane based on the 3 non-collinear points. So this plane would be plane ABC. All right, so let's flip it over. Let's finish the back real quick. Now, notice in the front, let me go back. The bullets have been done for you. One of the things I'm going to check to see if you did the notes correctly is that you create your own bullet for these last 2 postulates. So first postulate, which is usually the most missed question of the first test. So it's important that you memorize this fact. Okay? This accepted fact. 2 plane postulate. I'm going to highlight this. If 2 planes intersect, then they intersect in exactly 1 line. Okay, exactly 1 line. So what you have here is, I hope you can see a little bit with the coloring, that you have 2 different planes, a little darker gray plane, a horizontal plane. This one here could be our horizontal plane in a way. And then we have the lighter plane, plane RST. Okay, so we have plane STW and plane RST. Now if I was to find the intersection, most students want to say, well, it intersects at that point. No, the point of intersection, if you can see, is exactly a line where the planes meet. And that line would be the name of that line. I'm hoping you can see that it is ST or TS. And notice the symbol was already given to you. So you need to memorize that if two planes intersect, then they intersect in exactly one line. So that's something you might want to write a little bullet, a main idea, a question for yourself. All right, so let's find the intersection of the figure at the right. So we're looking at this parallelogram prism. It says plane GLM. Now, when you are given a plane, you need only at least 3 non-collinear points to name that plane. To help you make sure you're identifying the correct plane, because if you're going to look at 3-dimensional shapes in prism, I would just follow the order of the points, and then you'll see which plane they're referring to. So if I go to G to L to M, this is referring to the top plane, okay? So that would be the top. Now, I'm going to do the same thing for LP, N. So I'm going to start at L, then go to P, then N. This is going to have to be this front right, maybe. I'm going to just shade it a different color. And they want to find the intersection. So they want to see when the blue plane touches the green plane. And hopefully you see that that intersection comes in the form of this line, which would be LM. But then we have to put the line symbol above it to identify and indicate it's a line LM. If you just put LM, that would be marked wrong, because that's stating a different statement. LM without a symbol is saying the distance between LM. Whenever I do that, that means distance. Okay, and we're going to get into that next. So, but if you put a symbol above it, it's saying a whole nother thing. Okay, all right. So now they want us to look at line KP. Line KP. So I'm gonna probably should do some highlighting that make that look a little bit better. But now I'm going to highlight or a different color line KP. There's line KP. Okay. And now they want us to look at plane KJN. So if I look at plane, I'm going to highlight that part. KJN is now the bottom plane right there. All right, so where does the line KP and the plane KJN intersect? Where do they touch? Where? I'm hoping you see that it happens all right there. So it would be at segment KP, okay? Segment KP. Remember, the line extends all out, okay? So we're talking about that point of intersection, point where they touch. So our last postulate, which is our 3-point postulate, a 3-point postulate states that through any 3, remember it has to be non-collinear points, there is exactly one plane. Alright, so that might help you get an idea of main idea statement or something to put on the left side, because you're responsible for that. And our last 2 vocabulary words will be coplanar, which I'm hoping will relate it to what we learned about collinear. So keyword, or one of the root words, is right there, planar. Okay, so hopefully you see that we have to be dealing with planes. So coplanar points are points on the same plane. Points that are not, if they are not on the same plane, they're going to be called non-coplanar. Lines that lie in the same plane. So we had points that lie on the same line, but if we're talking about lines that lie in the same plane, again, what's another word for line? Linear. So if they're on the same plane, they are collinear. Okay, they're collinear. All right, so we're taking the terms, how to label these basic ideas in geometry, and we're going to expect you to draw the relationship. So says to draw a label figure for each of the relationship. Point S lies on line point R. Now you're going to see this. It's abbreviation for answers may vary, meaning there's many different ways to get the right answer. But basically, since I'm talking about a point lies on line PR, S is collinear to line PR. So I'm going to draw my line. I have to have arrows to show that it's extending and endlessly. It's going endlessly in both directions. So all I really need is the arrows. I don't need the dots. Arrows indicate that it's going to continue in both directions. The name of the line is PR. So I need the points P, and I need the points R. You can put them at the bottom. And S lies on that line. So I could have S here. I could put it over here. This is why I'm saying answers may vary. But those 3 points must be collinear. They have to be on the same line. And then on number 2, we have points A and B are collinear, but points F, A, B, C are non-collinear. So we know that A and B, right here, they're collinear, so we know they're on the same line. There they are, okay? Points A and B are collinear. Now we have F, A, B, and C are non-collinear. So which points are not on the line? I'm hoping you're seeing that F and C are not on the line. So I could have F here. I'm going to have C here. I could put it anywhere as long as it's not on the line. Okay? Not on the line. Again, answers can vary. So try number 3. Line M contains A and B, but does not contain C. Remember what just a capital letter represents? Remember what the subscript represents? So that we have the correct figure drawn. So I'm hoping we needed a line, so you should have arrows. And then you need, let me fix this a little bit, sorry. We need the lowercase m, cursive m, subscript m, next to the arrows. And then we need A and B. It's containing to that line, but C does not contain to them. So we need points A and B somewhere on the line, and C not on the line. Okay, pretty simple. Lines A, B, and C are coplanar, but do not intersect. And I'm hoping you remember what type of lines never intersect or do not intersect. And let's see if you know what they look like, what they're called. But because we're dealing with coplanar, coplanar means we need to show and indicate a plane. What shape do we use to indicate that? It's on the front of the notes. On the other side, we need a parallelogram, okay? So the parallelogram is telling me we have a plane. And then we have lines A, B, and C that are coplanar but do not intersect. All right, so if lines A, and let me make that a little bit better. There's A. Line B and line C are coplanar. I just need them somewhere inside that plane. And if they do not intersect, they are what we call parallel lines. And we're going to practice this some more, but I'm just going to let you know get you ahead of the curve. If they do not intersect, we call that parallel. And in geometry, we have to see symbols. So you're going to start seeing that this is about using symbols, understanding the symbols, and applying the symbols and the relationships that occur with them. So to show that lines are parallel, you would see an arrow, the same arrow on all 3 lines to show that they're all parallel, going in the same direction. Okay? So please complete these notes. Get your main idea questions done. This side should be filled out by you. The left side, sorry, that doesn't make anyone dizzy. And thank you for experiencing your first flipped classroom. I look forward to us getting right into it and moving on and building off of these postulates and axioms and getting ready and strong for our proofs. All right, thank you. Bye.